All right, AP. Let's do one more sample problem with temperature conversions. Let's go the other way. We've been talking about Fahrenheit temperatures and then converting them into Celsius or Kelvin. Let's go the other way. Liquid nitrogen, which is often used as a coolant for low temperature experiments, has a boiling point of 77 Kelvin. If you don't know, that's very cold. It's very cold. But what temperature is this on the Fahrenheit scale? Go ahead and try to calculate this on your own. Please generate a response. Press pause if you need to, because here comes the solution. Now, we're trying to go from Kelvin to Fahrenheit scale, the Kelvin scale to the Fahrenheit scale. But you can't go, I mean, you can, but you can't, we're not going to go directly from one to the other. We're going to go by way of the Celsius scale. So we're first going to take the 77 Kelvin and we're going to go to the Celsius scale. So we know that temperature in Celsius is equal to your temperature in Kelvin plus 273.15. So what it looks like is 77 minus 273.15. Okay, and that's going to give us negative 196 degrees Celsius. So that's very, very cold. Yeah, that's very, very cold. That's well below the freezing point of water here. Now our next step, we're not supposed to report our response in Celsius. We're supposed to report our response in Fahrenheit. To convert to the Fahrenheit scale, we use the equation temperature in Fahrenheit plus 40 divided by temperature in Celsius plus 40. That ratio should equal the 9 degrees Fahrenheit over the 5 degrees Celsius. So we have our temperature Celsius, so we're going to go ahead and plug that in because we just determined that in this first step here. We don't know what the temperature in Fahrenheit is because, again, that's what we're trying to figure out here. And so it's going to be very easy. I'm just going to add this 40 degrees here. Well, that's going to bring the temperature up. It's going to become less negative, so that's 156 degrees Celsius. That's going to be my denominator here. But I know that this this fraction here is going to be equal to this 9 over 5, the Fahrenheit over Celsius. So it's very easy for me to take the next step of multiplying. I hope you can see what happened here. I multiplied both sides by negative 156 degrees Celsius. And so I multiplied both sides. That means that this got to cancel, and now it's going to be multiplied over here. And so that's why we can write this equation now as the final, the Fahrenheit temperature plus 40 is going to be equal to, again, this 9 over 5 ratio multiplied by the negative 156 degrees Celsius. That is going to equal negative 281 degrees Fahrenheit. That's not my final answer because I haven't solved for, T sub f, because I still have this darn 40 here. I'm going to subtract that from both sides, so that way I can cancel. Subtract that from both sides. And remember, this is negative, so if I'm subtracting, this is actually getting smaller. It's getting more negative. And so it's actually going to be, subtracting the 40 is going to be negative 321 degrees Fahrenheit. If this didn't occur to you at once, if you weren't sure how to keep going, please spend a minute or two looking through this math so that you understand mathematically what functions are being taken out here. This is not something that is going to go okay with you if you just skip over it and you think to yourself, oh, I'll get this later. Because we won't be going over this later. We'll be going over new stuff later. So get it now. If you need to spend more time on it, spend more time on it.